This little video is an explanation of the structure of the prime number sequence. The prime numbers have traditionally been thought of as being a hopeless muddle, but I hope to show that it follows a very definite pattern, and the prime numbers share some of the properties of recurring decimals and is very much ordered. So we'll take it slowly, a little bit at a time. Prime number sequence itself, denoted by the letter P, which is equal to the first 10 primes are 1, 2, 3, 5, 7, 11, 13, 17, 19, 23, and carries on, of course, 29 and such like. The prime number sequence, the first little bit of which is here, is generally reckoned to be without any order at all. They're in a hopeless muddle. But we aim to show in this little video that there is a very definite order to the prime number sequence. And the secret is, first secret at any rate, is that the prime number sequence is composed of sections separated by the squares of the primes. So there are the squares of the primes up at the top, 1 squared, 2 squared, 3 squared, 5 squared, and they mark the beginnings and ends of the sections of the primes. So section A is 1, 2, 3, section B is 5 and 7, section C is 11, 13, 17, 19 and 23. And this doesn't just apply to the first 3 sections, it applies ad infinitum, which we shall say again in just a moment. Now, the sections of the prime number sequence are taken from, each section is taken from a regular sequence whose different sequence is similar to a recurring decimal. Take a recurring decimal like 1 over 7, has a period of 6, and it goes 0.142857, 142857, 142857, ad infinitum. And these regular sequences from which the sections of the prime numbers are taken have different sequences like that repeat forever. Let us now look at the regular sequences. The first regular sequence, denoted by S1, consists of all the integers that are divisible by 1. Now, of course, every integer is divisible by 1, and so S1 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, ad infinitum. It is just simply the integers, whose different sequence is very much like a recurring decimal, and it is 1, 1, 1, 1, 1, ad infinitum. The difference between successive terms in that sequence is just 1. Now, if we take the section from it between 1 squared and 2 squared, that's to say between 1 and 4, we get the 3 first primes of 1, 2 and 3. And that is the first section of the prime number sequence. Now, the second regular sequence from which we take a section out for the prime number sequence, the second regular sequence we'll denote by S2, and it consists of the integers not divisible by 2, or prime to 2. And they, of course, are the odd numbers, and so S2 equals 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21 ad infinitum, and the different sequence for that is simply 2, 2, 2, 2, 2. The difference between each successive term is obviously 2. Now, to gain a section from the prime number sequence, we take the section between 2 squared and 3 squared, that's to say between 4 and 9, and that yields up 2 primes, 5 and 7, and that is the second section of the prime number sequence. Now we turn to the next section, the third section that we're going to take out of the regular series. Now, the regular series is, this time now, is S3, and I've written it down there, 1, 5, 7, 11. They're numbers that are not divisible either by 2 or 3. Gradually building the base primes up. So 1 is not divisible by 2 or 3, nor is 5, but the numbers between 1 and 5 have been eliminated because they're divisible either by 2 or 3. So we just cast our eye along there and check that 2 nor 3, neither 2 nor 3 divide into each of those numbers, 7, 11, 13, 17, 19, 23, 25, 29, 31, 35. Take that 25, the factors of 25 are 5 times 5, and it's not divisible by 2 or 3, nor is 35 divisible by 2 or 3. But you will notice there are a number of primes in that sequence. It's not all primes, 25 is composite, 35 is composite. Let's note that it is a regular sequence. Between 1 and 5 there's a gap of 4, between 5 and 7 there's a gap of 2, 7 and 11 there's a gap of 4, 11 and 13 a gap of 2, and that's how the differences go, 4, 2, 4, 2, 4, 2, 4, 2 ad infinitum. Now we take the section between 3 squared and 5 squared, up to but not including 5 squared. 5 squared is the first composite in that series. 3 squared is 9, 5 squared is 25, so the section in that sequence between 9 and 25 has 5 primes in it, 11, 13, 17, 19 and 23, and that is the third section of the prime number sequence. It's section 3 of the prime number sequence. If you remember right back at the beginning we had A, B and C, well this is section C, and those 5 primes are the third section of the prime number sequence. Now what we are doing is taking some regular sequences, that's divisible by 1, not divisible by 2, not divisible by 2 and 3, and the next one which we're not doing is not divisible by 2, 3 or 5. We're taking these regular sequences and taking a section from them, a section determined by the squares of the primes, which we've had a look at, and that yields up 3 sections. We've just done the first 3 because they're the most clear. It applies to all the rest of the primes. The first section yields up 1, 2 and 3. The second section yields 5 and 7 as prime, and the third section yields up those 5 primes, 11, 13, 17, 19 and 23. Notice how the squares of the primes mark out the beginning and ends of each section. So 1 squared, that actually runs through the number ones, which we're going to include. 2 squared is 4, that's the break between, that's halfway between 3 and 5, and then that's 2 squared. 3 squared is 9, which is between 7 and 11, and then 5 squared is 25, between 23 and 29. That marks out the beginning and ends of the sections. So it's an amazing setup that the prime number sequence is composed of sections separated by the squares of the primes. Now we mustn't think that the order we found and tried to explain only applies to the first 3 sections. This process that we've been looking at, a regular sequence and then a section being taken from it to give a section of in the prime number sequence itself, this process continues forever. So in general the nth section lies between pm squared and pm plus 1 squared and is taken from the regular sequence Sm, which is prime to a group of primes which I call the base primes, Bm. If you are interested in pursuing the matter further, can I recommend to you this book, The Pattern of the Primes, which deals with this, and also prime twins and Goldbach's hypothesis and the nth prime and a number of other interesting topics. I commend that to you. You can find it on Amazon, of course. Now, this is the end of my little presentation, which I hope you've enjoyed. I commend the book to you. I commend these ideas to you, and hope I've managed to carry you through. Thank you.